Hello everyone, my name's Valerie and I'm the Outreach Coordinator of Future Energy Systems, also known as FES. FES is a research program at the University of Alberta, which is focused on exploring the energy transition. Thank you so much for joining us today to explore solar energy. In this series of clips, you will learn the basics of solar energy, do a craft that reminds you of the power of the sun, and then try and cook with it. If you want to stick around longer after that, you can meet two of our researchers that are exploring new ways to make solar materials. Have fun! This first part will explore the basics of solar energy and lead you through a craft where you'll make a stained glass window. Here are the supplies you'll need. Are you ready? Hi everyone, my name's Valerie and I'm the Outreach Coordinator for Future Energy Systems. But what is energy? Energy is the ability to do work, and it's all around us. From the food we eat, to the cars driving down the street, to the lights in our house. We all use energy every day. For most of the energy we use, it started with the sun. The sun shines and makes plants grow. These plants are eaten by animals, including us humans, to give us energy. But a long time ago, some plants died, were buried for millions of years, and turned into fossil fuels. And now we use the sunlight they captured millions of years ago to run our cars, industries, and much more. But can we use the energy directly from the sun? Yes. One of the most promising technologies for a green future are solar panels. These panels are capable of turning sunlight directly into electricity we use to power our houses, schools, and even our phones. But what is this electricity and what is it made of? Everything you see around you, this sign, the walls, the chairs, are all made of atoms. These tiny little pieces contain a nucleus and electrons. Electrons are little charged particles that orbit the nucleus. Normally, these electrons are stuck circling the nucleus. But some atoms like to share their electrons with their neighbors, and this allows electrons to move from atom to atom. This movement of electrons is what happens in the wires charging your computer or your phone. Electrons travel from the plug in the wall, along the wire, into your computer. But what makes these electrons move? Like a soccer ball in the grass, which won't move until you kick it, you have to use the energy from your foot to get it to move. That's what solar panels are able to do. Solar panels are made of atoms and electrons. When the light shines on the solar panel, the sunlight gives the electrons energy, allowing them to move. Solar panels are the driving force that make the electrons move along the wire. One day, we might be able to power entire cities using sunlight. There are a lot of great things about solar energy and solar panels. Solar energy is renewable, which means it's never going to run out. The sun's going to keep shining. Because it isn't a fossil fuel, it's going to reduce our greenhouse gas emissions, which can contribute to climate change. It can be done on a small scale by individuals, solar panels on your roof, or on a large scale, entire fields of panels. It's quiet and relatively cheap compared to other renewable energy methods. However, there are some challenges with solar energy. Can you think of any? Well, the sun doesn't shine all the time. Sometimes it's cloudy, sometimes it's night. If you live in Edmonton like me, in the winter, it's dark a lot of the time. Sunlight is intermittent, which means the electricity produced from solar energy is also intermittent. This is a problem. When I plug in my phone or computer, I want to know that there's electricity. So how do we deal with this? One method is energy storage. However, it can be quite expensive and take up a lot of space. You might be able to use it for your home, but how would you use it for an entire city? There are researchers looking for solutions to this problem. Another way to deal with it is to put the energy back into the grid where we currently get our energy. However, the intermittency of solar energy makes this hard because we never know how much is going to go into the grid and how much is going to need to come out. Another challenge is efficiency. How much sunlight is turned into electricity? It's estimated that efficiency is between 11 and 19%, according to Clean Energy BC. That's a lot of wasted sunlight. So researchers are looking for solutions to improve the efficiency of solar panels. So we've learned that solar energy and solar panels are an important part of the energy transition away from fossil fuels. However, there's still a lot of questions that need to be answered and research that needs to be done. And that's what many researchers at Future Energy Systems are doing. So today, we're not going to build a solar panel at home, as cool as that would be. We are going to make beautiful stained glass windows, something that will remind us about the amazing power of the sun. Here are the supplies you're going to need: transparent paper, tissue paper, scissors, tape, a hole punch, a piece of string, and a template if you want. So I've decided to make a sun. Here's my template. I'm going to tape it down to the table. I have a piece of transparent paper cut to about the same size. I remove the backing and tape it over the template with the sticky side up. Now I'm going to fill in the template with these little pieces of tissue paper. You could do all one color or lots of colors like I am. When you've filled the whole image, take another piece of transparent paper, about the same size, and remove the backing. Lay it on your completed image to make a sandwich. Remove the tape, holding the window to the table. If you can't get the tape off, you can just trim the edges, which you're going to do now to remove any sticky bits where it didn't meet perfectly. I'm going to use this blue tape to make a border, but you could do any color or have no border. Use the hole punch to make a hole at the top of the window and tie a piece of string to make a hanger. And here you have your beautiful stained glass window. Find a big window full of sun and keep learning about the energy all around you. Thanks so much for watching. Bye! How did your craft go, everyone? Is your window letting the sun in? Now we're going to use the sun to do something different, to use it for cooking. We're going to make solar ovens, and here are the supplies you'll need. I hope your food turns out delicious. Whew, it's pretty warm out here. I can definitely feel the heat from the sun. Today, we're going to cook with the sun by making solar ovens. Cooking with the sun? Let's think about that. We use the sun for light and to make electricity with solar panels. The sun gives us energy by making plants grow, which we then eat. We can also burn wood for our campfires to cook food, and those trees originally grew because of sunlight. To cook our food, we generally use stoves. If you look at your stove, it might use electricity if it's an electric stove, or it could use natural gas or propane, which are fossil fuels. Or if you're like me, you might use your microwave a lot, which uses electricity. But we can also directly use the heat and light from the sun to cook our food. Instead of using a solar panel where the energy from the sun is transformed into electricity, we can trap the energy from the sun inside of our solar oven to cook our food. Light is made up of photons, and when these interact with other molecules, they get excited and they start to move. This movement creates heat. Have you ever gotten to your car after it was sitting in the sun all day? It's hot, right? This is the same idea. So to make our solar oven, here are the supplies we're going to need. A pizza box or shoe box, a marker, scissors, tape, glue stick, ruler, black paper, tin foil, saran wrap, newspaper, which I've already crumpled up. I also have a pie plate that I will put my food on so it doesn't get my oven dirty. And finally, something to cook. You could do s'mores, toast, a hot dog, nachos, even heat up leftovers. I'm going to do melted cheese and crackers. First, we're going to draw a rectangle on the lid an inch or two in from the edge, other than the edge at the hinge of the box. Now, get an adult to cut the 3 edges to create a flap. Line the inside of the flap with tin foil. Make sure the shiny side is out. You can glue or tape it down. Now open the box and tape down a double layer of saran wrap on the inside of the window. Tape all around the edges to keep the heat trapped inside. Line the bottom of the box with black paper. Black absorbs heat, which will help the food cook. You also want to insulate the box. I'm going to use crumpled up newspaper, but you could use fabric. You need to attach around the 4 sides. Make sure you can still shut the box, but that you're reducing the air and heat that can escape. Now we're going to set up our oven outside. I'm going to put the cheese and crackers on the pie plate inside. You want to cook when the sun is high overhead. Tilt the flap so that the tinfoil is reflecting sun into the box. You may need to move it throughout the day. The heat will start to build up inside because it can't escape through the saran wrap or the newspaper we use to insulate. Use a ruler or stick to hold it open. It may even be possible to cook with a solar oven on cloudy days, though it will take a lot longer. We're going to leave the box out here for a while until our food is cooked. It will take longer to cook with a solar oven than a regular oven. Make sure you use oven mitts to take the food out because it sure is hot in here. And here's my melted cheese and crackers. By using the energy of the sun to cook our food, we've cooked without polluting and reduced our electricity and fossil fuel use. Solar ovens are also very useful in places that don't have access to a lot of fuels. Now it's your turn to design your solar oven. Try different materials to insulate, different shapes of the box, and different angles to the sun. Try a lot of different ways to engineer your best oven. Thanks so much for watching and happy cooking! Were you successful? I know the first time I tried my solar oven, I had a hard time getting the angles of the sun right, but after that, much better. Now that you've tried your own experiments, let's meet some researchers from FES who are studying solar energy. Our first researcher is Michelle Ha, who's studying the molecular structure of materials, including those in solar panels.
Hello everyone, my name is Michelle and I'm a PhD candidate in the Department of Chemistry at the University of Alberta. Today I will be talking about a technique we use in our research called solid-state nuclear magnetic resonance spectroscopy, or NMR for short, and how we can use NMR to understand the structure of energy materials. Everything around us is made up of matter, from the food that we eat, to the air that we breathe, or the screen that you're using to watch this video. And all this matter is made up of atoms. When these atoms interact and bind, they create molecules and molecular structures. But why do we want to learn about molecular structures? Think of it like playing with Legos. While each individual Lego block is important, we have to understand how the blocks fit together to create new designs. Likewise, we also need to understand how atoms work together to create different molecular structures, which can allow us to create better materials for many purposes, such as harnessing energy. So how can we learn more about molecular structures? What techniques can we use to study such small interactions? That's where solid-state NMR comes into play. Solid-state NMR is a powerful technique since we are able to study molecular structures at the atomic level. When we put the molecules in a strong magnetic field, the nuclei of some atoms, or the very center of some atoms, will begin to act like tiny magnets. When we apply a radio pulse, the nuclei will resonate at a specific frequency. Think of it like tuning a guitar. When you pluck a guitar string, it will resonate at a specific frequency according to the note that you want to play. These resonant frequencies are then measured and converted into peaks on a graph, which we call an NMR spectrum. Depending on how high the peak is, the signal intensity, what the peak looks like, the line shape, or where the peak shows up on the graph, the chemical shift, we are able to determine what is happening around these specific atoms. Using this information, we can unravel the complex structure of our materials and learn how to develop newer and better materials. Solar energy is a renewable resource that uses the energy from the sun to produce electricity. Since it's renewable, it means it never runs out. It also doesn't produce greenhouse gas emissions, meaning it's an important tool against climate change. One example of an exciting solar energy material is perovskites. This unique compound has the ability to harvest light, which is then converted into energy when used in solar cells. In our research, we use solid-state NMR to understand how these materials are structured and what gives them their unique ability to convert light into electricity. By analyzing our NMR spectra, we can create fingerprints that relate to each specific structure and their unique properties. Using these fingerprints, we get a foundation on what structure provides the best solar energy properties. With NMR, we are now able to understand how these materials are structured and what gives them their unique properties in order to develop new and improved energy alternatives. Thank you so much for joining me today as we learned a bit about what solid-state NMR is and how we can use it to study energy materials. Also, a special thank you to all our sponsors.
Our second researcher is Aaron Kirk, who's using computer algorithms to develop better solar photovoltaics.
My name is Aaron Kirk, and I'm from Niagara Falls, Canada. I'm a master's student at the Department of Chemistry here at the University of Alberta, and thank you for attending my talk. My research focuses on solar cells or photovoltaics, but first let's talk about food. Imagine we wanted to make the best tasting sandwich possible. This isn't such an easy task because sandwiches are complex. They have many layers like meats and cheese, and some of these layers need to be heated or sliced like a tomato. So making every single recipe could take years. But if you were clever and you wanted to save a lot of time, a computer could help you out. So normally when we optimize something, we are just trying to make the best version of that thing. So we're trying to make, say, the tastiest sandwich possible. Normally when we do this, we can change one thing at a time, like the sauce or the meat, and we test it. You could change two things at once, but changing both the meat and the sauce, it would be hard to tell which one of those two things made the sandwich better or worse. Maybe both of them made it better or worse. And this is where a computer can help you out. So with the computer's help, you can change 2 or 3 or maybe even 4 things and test it. And then the computer would help you figure out what in the recipe made that sandwich better or worse. This means you could make significantly fewer sandwich recipes while still trying every single sauce, meat, cheese, or vegetable. And the computer would help you track down the best tasting recipe while saving you a lot of time and a lot of ingredients. And while sandwiches might not be able to help us fight climate change, solar cells could. So what is a solar cell? Solar cells are capable of turning sunlight directly into electricity, the same electricity that could be powering your laptop right now. And they do all of this without producing any carbon dioxide. And this is great. So why aren't there solar cells everywhere? The problem is they're pretty expensive, and people have been looking at making them cheaper for a long time. One way of making them cheaper is to make them a bit more efficient at turning this sunlight into electricity. So the more efficient the solar cell is, the cheaper it is. So on the left on this slide, we have what we normally see for solar cells. These big dark blue tiles on rooftops or in farmers' fields. And they can be very heavy, and as a result, they're hard to install. But I work on a new type of solar cell, the one shown on the right. It's an organic solar cell, and these can be made as thin and as flexible as a credit card. However, they also contain a lot of layers, much like a sandwich. And each of these layers needs to be made in a specific way for it to produce as much electricity as possible. So my colleagues and I have developed a method with the help of computer algorithms you can think of as just a lot of math on a computer to help us decide or help us figure out which recipes among hundreds could make the best solar cells possible. So these two pictures here are from devices actually made in our lab. And you can see that they're quite small, and they're also very, very thin. They're about a millimeter thick, so maybe 10 sheets of paper thick. So what we do when we are optimizing or trying to make the most efficient solar cell possible, we start by picking a few layers we want to improve, and we think of a few ways of actually improving those layers, say by heating them up, or by mixing in another ingredient. And once we've made a few solar cells with the help of the computer to decide which recipes specifically to make, we actually make them. And then we take those results after we've made them and tested them and put it back into a computer. And this computer helps us figure out which recipe makes the most efficient and therefore cheapest solar cell possible. So on this slide on the left, we have a topographical heat map of Edmonton. So if you look at the little color chart on the right of that image, you can see that areas with red or white coloring have the highest elevation, and areas with green or blue have the lowest elevation. And as you'd expect, the river valley, which goes right through the middle of Edmonton, has the lowest elevation. On the right, we have one of our machine learning computed or built maps. And it's the same idea, where if you look at the color bar on the right, this time the yellow areas are the highest. PCE, which is a short form for efficiency, which I had mentioned earlier. So the more efficient a cell is, the cheaper it can be made. And these blue areas, these dark blue areas, are lower efficiency. And so these maps, which are produced by the computer, help us figure out which recipe exactly could make the most efficient solar cell. So each of these colored dots are devices we actually made and tested in the lab, and they have slightly different recipes. And so if we could, we would probably make a device that would fit on the map in the top left corner. So as you can see on that map, that is the brightest yellow region, and so it would be the most efficient region, or the most efficient recipe would give you a dot somewhere in that top left corner. And that is the computer telling you which recipe would make the most efficient and therefore cheapest solar cell to make. Thank you very much for listening to my talk today.
Thanks so much for learning about solar energy with us. I hope you had a lot of fun. Make sure to subscribe to our YouTube channel so you don't miss any of our exciting content, and check out the links below. There's so much to learn as we explore our energy future.